Look at an active commercial construction site. You see excavators moving earth, tower cranes swinging steel, and tons of wet concrete being pumped into complex foundation grids. It is a loud, chaotic, and incredibly physical environment. But look closer at the geometry. Every single piece of steel and every cubic meter of poured concrete you see is entirely downstream of a strict, invisible legal framework. That framework is the National Construction Code, or the NCC, the primary technical document governing building work across Australia. The NCC sets the mandatory baseline requirements for safety, health, amenity, and sustainability. It dictates the minimum standard a structure must achieve before it can be legally occupied. For a site manager, the NCC is the mandatory baseline. Failing to meet it can result in an unoccupiable structure and significant legal liability. There is a common industry misconception that the code acts as a dictatorial list of instructions, a strict recipe book that tells you exactly what size nail to use and where to put it. In reality, the NCC is a performance-based code. This means the legislation dictates the required destination, but it does not mandate the exact path you have to take to get there. Take a look at the geometry of these timber roof trusses. The code mandates that a structure must withstand dead loads, the permanent weight of the building itself, and extreme wind actions. That is the required performance destination. The legal standard requires the roof to remain stable during a cyclone. The builder and engineer on site, however, have to decide exactly how to design, source, and construct those trusses to prove they hit that standard. Understanding this performance-based flexibility allows builders to pursue engineering innovation and solve problems directly on the site. To navigate this system, you first have to understand its macro structure. The NCC is divided into 3 distinct volumes. Volume 1 covers multi-residential, commercial, industrial, and public assembly buildings. In the code's classification system, these are known as classes 2 through 9. Volume 2 covers smaller-scale residential structures. If you are building a suburban house, a small shed, or a carport, classes 1 and 10A, this is where you look. Volume 3 is the Plumbing Code of Australia. Unlike the first 2 volumes, its rules for drainage and plumbing systems apply across all building classes, from a backyard shed to a 50-story high-rise. The building's classification dictates which specific volume a professional must consult. This gets complex on modern sites. A single mixed-use development might have a retail space on the ground floor and apartments above, containing multiple classifications. The builder has to navigate different volumes simultaneously to ensure the entire site complies. Once you are in the correct volume, you encounter the core engine of NCC compliance. It operates like a logic gate, starting with an uncompromised baseline known as the performance requirements. Performance requirements are the only technical provisions in the entire NCC that are strictly mandatory. You have to meet them. How you meet them is where the logic gate splits. The first pathway to satisfy this mandate is the Deemed to Satisfy, or DTS, solution. DTS is the pre-approved recipe book. If a builder uses the specific materials, dimensions, and construction methods listed here, they are legally deemed to have met the performance requirement. The alternative pathway is the performance solution. This is a custom-engineered approach. If a builder wants to use a novel design or a material not found in the DTS recipes, they can, but they must legally prove their design meets the mandatory baseline using rigorous evidence, testing, or expert verification. These pathways are not mutually exclusive. A single building will often use a combination of both solutions across different structural elements. Choosing the correct pathway at this logic gate is a critical project decision. It dictates the budget, the timeline, and the capacity for innovation on the site. To navigate this logic tree, professionals have to decode the NCC's structured alphanumeric numbering system. Every clause across all 3 volumes uses the SPTC system: section, part, type, and clause. Look at this page from Volume 2. It shows a specific structural regulation labeled H1P1. Breaking this down, the H identifies the broad section of the code, and the 1 identifies the specific part within that section. The critical indicator here is the P. It stands for performance requirement. This instantly tells the reader that this clause is legally mandatory. Reading the text, H1P1 dictates the physical requirement. The building must resist expected design actions and sustain local damage without collapsing. Now, look at this separate page from the code, labeled H1D1. This gives us a specific how-to recipe that satisfies that mandate. Notice the D in the middle. The D indicates a deemed to satisfy provision, meaning this is an optional pathway. You can see the internal wiring of the code right here. Paragraph 1 under H1D1 explicitly references H1P1, directly linking this optional recipe back to the mandatory requirement we just looked at. You might also see other letters in the type position, like O for objective or F for functional statement. These exist to provide guidance and context, not legal obligations. Mastering the SPTC syntax allows a builder to look at any single line of code in a massive document and instantly know whether they are reading a strict legal mandate or an optional engineering pathway. Let's step out of the documentation and apply this regulatory logic back to the physical reality of site execution. Look at this dense steel rebar cage being formed for a structural wall. Which compliance pathway permitted its installation? The standard repetitive elements of this foundation likely follow a prescribed deemed to satisfy pathway. The builder uses standard dimensions from the code for speed and efficiency. However, the massive load-bearing columns themselves might utilize a performance solution. By legally verifying their custom design, the structural engineer can optimize the amount of steel required, pushing past the limitations of standard tables. These legal pathways physically touch on site. A custom performance solution steel frame sits next to a standard DTS brick wall, forming a cohesive structure. What looks like a single building is actually a physical mosaic of different compliance pathways working together in real time. The National Construction Code operates as a calibrated engineering logic system designed to facilitate construction through a framework of safety. Decoding the SPTC syntax and understanding the duality of these logic pathways provides the technical autonomy necessary to lead a project. Mastery in construction requires knowing how to assemble materials. More importantly, it requires understanding the regulatory architecture giving you the legal authority to build.